Today we are diving into some really fascinating new research. It's about a groundbreaking way to train AI. Now think about this. Instead of building these super complex simulations from the ground up, what if we could teach an AI how to do things just by having it read the instructions? Instructions that are already out there, just hidden in plain text all over the internet. I mean, really, what if the instruction manual for building a smarter AI was already written, and all this time, we just didn't know how to read it? That's the huge idea we're exploring today. This idea that a massive, untapped library of problem-solving experience is hiding in plain sight. So let's start with the big picture here. We're not just talking about getting a slightly smarter chatbot, no. The real goal, the holy grail, is to create true AI agents. These are autonomous systems that can understand a complex goal you give them, like, say, plan a 2-week trip across Europe, and then actually take all the steps to make it happen. Right, because for an AI agent to actually be useful, it can't just talk a good game, it has to act. And in our digital world, acting means using tools. You know, when you book a flight or edit a photo, you're using a website, an app. Well, AI agents need to learn how to use these exact same kinds of digital tools, things like APIs, which are really just the way different programs talk to each other. That's how they're going to get things done for you.
Okay, but if the vision is so clear, why don't we have these super powerful agents running our lives already? Well, that brings us right to the central problem, a major bottleneck that has really slowed down progress in this entire field.
The whole bottleneck really comes down to just one thing, a massive scarcity of high-quality training data. See, for an AI to learn a really complex task, it needs to see thousands, maybe millions of examples of that task being done correctly. And creating all those examples from scratch, it's incredibly expensive and just takes forever. This diagram really shows you the heart of the problem. On the left, in part A, that's the old way, the typical synthesis pipeline. What researchers used to do is define a really small, limited set of tools and then try to simulate tasks with them. As you can imagine, this approach is super narrow and costs a ton of money. But the new idea, over in part B, is to build a pipeline that's way more diverse and scalable by tapping into a much bigger source of information.
Let me give you an analogy. The old way is kind of like trying to teach someone to be a world-class chef by only giving them a list of kitchen tools. You know, a knife, a pan, a whisk. Good luck. The new idea is like giving them every cookbook ever written and teaching them how to read the recipes. All of a sudden, you're not limited to what you can simulate. You're tapping into this vast ocean of existing human knowledge.
And this right here leads to the brilliant insight at the core of this research. It turns out the data isn't scarce at all. We've just been looking in completely the wrong place. The internet is absolutely filled with text that describes step by step how to do things.
This quote from the paper just captures the aha moment perfectly. It says, "Unstructured text serves as an untapped, scalable, and authentic source for synthesizing agent training data." Let's break that down. Unstructured text is just all the regular text online, how-to guides, tutorials, support docs, and it's an untapped, scalable, and authentic source, meaning it's a massive, real-world instruction manual that's been right under our noses the whole time.
Just think about a simple online tutorial, something like how to create a music visualizer in Adobe After Effects. To you and me, that's just a web page with some instructions. But to an AI, this text has everything it needs: a user's goal, the exact tools required, in this case, After Effects, and a super precise step-by-step workflow to follow. It's literally a perfect blueprint for a training example.
So the goal is to turn all these text-based recipes into training data. And in the world of AI agents, this kind of training data has a specific name. It's called a trajectory. Just think of a trajectory as a detailed log, a play-by-play of the entire interaction, what the user asks for, the AI's thought process, every single tool it uses, and the final outcome. Okay, so how do you actually turn all this raw, messy text from the internet into these clean, structured trajectories that an AI can learn from? Well, the researchers developed a systematic process for this, a whole pipeline they called GEM. It stands for Generation and Extraction of Multi-Turn Trajectories. The GEM pipeline has 4 main stages, and it's actually pretty logical. First, it filters all the text to find the good stuff. Then it extracts the key information from that text. Next, it generates a draft trajectory. And finally, and this is crucial, it refines and validates that trajectory to make sure it's top quality. So let's just quickly break down how each of these stages works.
First up is filtering. Let's go back to that After Effects tutorial example. The system basically acts like a super smart search engine.
It sifts through the entire internet and flags that specific web page as a promising candidate because it contains procedural, step-by-step instructions. It throws out all the junk, news articles, product reviews, everything else, and it just keeps the how-to guides.
Now, in the extraction stage, the system starts to really read and understand the how. It figures out the sequence of actions, the workflow. Step 1, import audio. Step 2, create solid layer. Step 3, apply audio spectrum effect. And then, and this part is really clever, it actually defines the digital tools, the APIs, needed to perform those actions, essentially creating them from scratch, just based on what's described in the text.
This is where the magic really happens. In the generation stage, they use a very powerful teacher model. Think of something like a state-of-the-art large language model. This teacher AI takes the workflow and the newly defined tools, and it basically role-plays the entire scenario. It generates a detailed conversation, maybe starting with a user saying, "Hey, can you make a cool visualizer for my new track?" It's creating the perfect, detailed training script for a student AI.
Finally, you can't just trust the data that gets generated. So in this last, crucial stage, the system refines and validates everything. It might make the scenario a little more complex. Maybe the user comes back and asks to change the visualizer's colors. And then it rigorously checks that the AI's response is valid, that every single tool call makes sense. Only the absolute highest quality, error-free data makes it through.
Okay, that is a seriously clever pipeline. But the billion-dollar question is, does it actually work? Does training an AI on all this data that's been mined from text actually make it better at doing things? Let's take a look at the results.
The answer is a resounding yes. The headline result is a massive 16.5% absolute performance improvement on a key industry benchmark. And let me tell you, that is not a small jump. In the world of AI, that is a significant leap forward in capability.
This table shows you just how big of a deal this is. Check it out. The base model Q1332B started out with an accuracy of around 28%. But after they trained it on the data from this GEM pipeline, its score shot up to nearly 45%. And here's the real kicker. This newly trained open-source model actually outperformed a powerful, well-known proprietary model on this specific benchmark. That is huge. It shows that sometimes having better data is even more important than just having a bigger model.
This next slide shows us why the training is so effective. It's not just that they have more data, it's that they have better data. This chart compares the average number of tool calls in each training example. Older datasets averaged about 4 tool calls per task, but the data generated by GEM averages over 16. That means the AI is learning from much more complex, realistic, multi-step problems, which is exactly what it needs to handle messy real-world requests.
So why does all this matter? What's the key takeaway? It's that this method isn't just teaching the AI to memorize a few tricks. The data is so diverse and so complex that it's actually teaching the AI a more fundamental skill: how to reason about new problems and figure out how to use tools in situations it's never seen before. It's learning to think, not just to imitate. And that could completely change the economics of training AI.
This whole idea of extracting experience directly from text is just incredibly powerful. You can imagine this same approach being used to teach a robot how to assemble IKEA furniture just by reading the manual, or helping a scientist design experiments by reading thousands of research papers. If the instruction manual for building a better AI was hiding in plain sight this whole time, it really makes you wonder, right? What other secrets to building AI are already written down, just waiting for us to read them?